Welcome back to Connected Farmer, your channel to keep you up to date with the latest trends in agriculture and livestock. Today, the issue is bee pollination in the United States, and the person to talk about this is Matt O'Neill. He is a professor at the Iowa State University, and he's going to explain a lot of things about this subject. Matt, how are you today?
I'm good. Thank you very much.
So, Matt, why bees are important to bring soybean yields or corn yields up?
That's a very interesting question because both crops do not require insect pollination to produce seed. Corn is a grass, it's wind pollinated, and does not require insects for seed production. Soybeans are a little bit different. Soybeans are domesticated, they've been bred for self pollination, and so we get most of the yield from soybeans without any interaction with a pollinator, bee, or any other type of insect.
So, and how do you start using the bees for your crops?
So we don't use bees for corn or soybeans in North America to improve the production of either corn or soybeans. There is some evidence in the scientific literature that soybeans respond positively to visits by pollinators, bees, and quite possibly other insects as well. But mostly the work has been done with honeybees and then wild bees that are found around the fields. And it's not quite clear how that visit is affecting yield, but there is some evidence that a yield improvement can occur when soybeans are exposed to these bees. And that has varied from 5 to sometimes as high as 18% improvement in yield.
Yes, and what specifically have you studied on this issue? What are the have you found out over the years?
Yeah, so I've been lucky to work with several people and groups here at Iowa State University, including Dr. Amy Toth and a bunch of graduate students and postdocs on a project where we explored how um, soybeans benefit or may benefit from bee exposure. And then we also looked at how honeybees respond to soybeans and variation around a soybean field. And what we found was, it's been very interesting. We've seen limited evidence in our part of North America, in Iowa, specifically central Iowa, that honeybees specifically improve soybean yield. Occasionally, we would see an effect where some fields in which we placed honeybees had higher yield, but it wasn't consistent across multiple years and locations. And in some ways, that's not surprising. Even if there is an effect, even if the bees are improving yield somehow, there's a lot of things that can affect yield both positively and negatively by the time that the plant is producing flowers to the time that the farmer is harvesting. And during the flowering period of soybeans in Iowa, the plant is also at risk for insect pests, specifically the soybean aphid. And so I don't know, but it is possible that whatever benefit the plant received from bee pollination could have been lost by feeding from other insects, like the aphid or any other of the a variety of insects that can feed on the plant in this part of the world. So that's half the story. The other
But
half,
the other half,
oh, go
yes.
ahead. Yeah. So the other half of the story, I think, is it's a little bit more hopeful and interesting, and that's how bees respond to soybeans, specifically honeybees. And just a little bit of background about the system. So I'm in North America, in central Iowa, and honeybees are not native to North America. They were brought to the Americas by European colonialist settlers. And soybeans are not native to North America either. They were brought from Asia, specifically parts of China. So there's a unique relationship. These two did not co-evolve together. And as an ecologist, you might not expect the two to get along, especially after soybeans have been bred for self-pollination and the flowers are quite small. They don't produce a lot of pollen, if any, and not a lot of nectar compared to other plants. But what we found was that when we put honeybees next to, and sometimes even in the center of a soybean field, that during the bloom period, when the soybean plants are producing flowers, which can last for several weeks in our part of North America, honeybees gained weight. And what I mean by that is not individual bees gaining weight and having to loosen their belts. What I mean is that the colony gained weight, and that weight is in the form of honey. So we didn't, I should also point out that while we were measuring the weight of the hives that we used in our various experiments, we also had other things that we were measuring. And one of them was the pollen that the bees were bringing back to the hives. We didn't see any soybean pollen in those traps. Sometimes we saw corn, but mostly we saw clover. So clover isn't grown very much in Iowa. It's a limited crop grown for forage for animals, but it's found in field edges, roadsides, urban areas. And it looks like the honeybees, wherever they were, could find that clover. We also looked for evidence of what the plants they were using in the nectar, in the honey. And we did see some soybean pollen in that honey. So we think that weight gain is a function of both soybeans, the nectar they're getting from soybeans, and the surrounding clover, as well as many as 20 other plants. So this is kind of interesting, right? That we're bringing the honeybees to the field. They are going out into the soybean crop. They're visiting the flowers. There's evidence that they're bringing back at least the nectar. And during that time, the hives are gaining weight. The sad part, though, is once soybean crops stopped flowering, especially soybean and clover, the hives started losing weight. Again, not the individual bees, but the whole colony. And pretty much all of the weight they gained, they lost. And that's a problem in our part of the world because soybeans stopped flowering in August. And we have a long time to go before winter and next spring, when all the other plants start to flower again.
That is happening right now there.
That's right. So it's, what is it, August 13th. So our soybean crop has stopped blooming. And if we had hives right next to a soybean field, I would expect them to kind of peak in their weight and their honey production. But here's an added wrinkle. Here's an extra chapter to the story. And what we found was something interesting from an experiment that a really smart graduate student did. Ashley St. Clair was noticing the weight loss and was also noticing from some other work that we were doing in prairies that from August into even October, there are native plants in North America that are flowering. And this caught her attention because she thought, well, could we reverse that weight loss by placing those hives next to a prairie? So she designed a little side experiment to our larger one and showed that you could rescue the bees from that weight loss by moving them to a prairie in August when all of the plants there, or many of the plants there, are still blooming. And so this prairie rescue effect is something that we published in a paper showing that this loss of weight is not inevitable. It could be reversed, and hives could continue to grow and maintain their weight going into the winter. And that's really important here because from year to year, honeybee keepers report overwintering losses that go from 30 to 60%. So every year they're losing that 30 to 60% of their hives. And some of that could be because they're starving. They don't have enough food to get through the winter.
And what do you see as what do you think that is the trend right now, considering this in pollination?
Yeah, so there's some large global issues when it comes to honeybees and wild bees and crop pollination. Wild bees in many parts of the world are in decline, both in terms of abundance and diversity. And honeybees, at least in some parts of the United States, are very challenging to keep because of overwintering losses and sometimes summer losses. Beekeepers report colonies dying for three main reasons. First is pesticide exposure. The second is pathogens. Um, these can be diseases like viruses, fungi, and also critters that feed on on the honeybees, like varroa mite. Varroa mite is a very important pest of honeybees in North America. And then the third issue is poor forage or a lack of forage. And these three things can interact to really negatively affect honeybees and make it very hard to keep bees. And that's an issue if you like honey, but it's also an issue if you have crops that need pollination. So in Iowa, this isn't such an issue for us because, again, we don't need honeybees to grow corn and soybeans. It would be nice if we had a more robust community of wild bees and honeybees for this added benefit of crop pollination of soybeans. But it's not a real driver for our land use and agriculture. But in other parts of North America, in some parts not quite far from us, like Michigan, there is a form of agriculture where they are growing crops that need insect bee pollination for optimal development. And so addressing those three issues, pesticides, pathogens, and poor forage, can go a long way to help conserve and improve the pollinator community.
Yes. Matt, is there something else would you like to add?
Yeah, if I could. So right now, I think maybe your listeners are um, maybe hearing kind of the typical thing from a scientist or an ecologist. Hey, it's
Mm-hmm.
bad. Things are in decline. This is terrible. Well, let me give you some good news. In Iowa, well, we started in Iowa, but now we have a national program approach to counter some of the problems affecting agriculture in general and specifically bees. I work with a group of people at Iowa State, scientists, extension agents, agronomists, weed scientists, economists, uh, multidisciplinary team on a project called the Prairie Strips Project. STRIPS is an acronym for science-based trials of row crop agriculture integrated with prairie strips. And the idea is to take a little bit of land out of production and add back to it perennial native vegetation. And in our part of the world, that native perennial vegetation is prairies. And prairies are a community of some 40 plus species, grasses, but also flowering forbs. And those flowering plants are the things that we tested in our first experiment that I told you about, that honeybees use, as well as other wild bees that are native to this region. What we found is that just taking a little bit of land out of production, up to 10%, is enough to have a substantial impact on honeybees. We can improve their honey yield by up to 24%. They overwinter better, they have greater survival, and we see a greater abundance of native bees when these prairie strips are in place. And you might say, well, what benefit is it to the farmer to do this, to take a little bit of land out of production? Well, one issue for our farmers is the soil erosion that can occur when for 8 months out of the year, the land is bare. So this perennial vegetation can act as a barrier to soil moving down a watershed, capturing that sediment, as well as the nutrients, the nitrogen and phosphorus that move with that soil. And that can improve the water quality for a watershed by having these barriers in place. Over about a 15-year period, we've demonstrated in fields, both experimental and commercial size, that this practice of taking a little bit of land out of production and putting in with prairie can have a big impact for a variety of factors that are important to farmers, but also important to the larger community. And recently, in the last U.S. Farm Bill, the federal government included this practice in a program called the Conservation Reserve Program that helps farmers practice conservation on their land. So it provides them a little bit of a payment for practices like the prairie strips practice.
There is really interesting. We can put the link over the video description. And thank you, Matt, for your time and all your explanations.
You're welcome. Hopefully that was helpful. And if you have any other questions, I'd be happy to take them. Thank you very much, Louis.